Welcome back, Pre-Calc. We're going to try to finish up with 9.9 section B in this video. Should be able to. So anyway, we're looking at this weird florist problem because it's kind of tough to come up with problems like this. But anyway, arrangement of 6 flowers and has 8 tulips, 12 roses. I guess underlying the number is just as important as the type, and 6 daisies to choose from. And it just wants to know the total number of ways to select 6 flowers from the florist, 26 flowers. So you can double check that it is 26 if you add those together. Again, I would say that the order doesn't matter, that you choose the 6 flowers. And instead of me trying to get fancy and doing this in my head and making a mistake like I did, I'm going to trust a calculator. So NCR. And by the way, there are probability questions that includes permutations. But so far we've only been seeing combinations, and I think the homework only uses combinations. But I hesitate to say always use a combination because we could easily come up with a problem. 26C6. There we go. We could easily come up with a problem where the order matters. So 230,230. For instance, I could come up with maybe you are trying to set it up where, well, this is probably a bad example, but if we're trying to select where the order did matter, like different ways that you can get first place, second place, third place, and it doesn't really pertain to this question. But anyway, what if we had the same thing, but now we're finding the probability that they're all roses, and again, it doesn't matter which rose is chosen first. So we have 12 roses to choose from. We want all 6 of them to be roses over this 26C6. Again, I'm not going to trust that I'm doing this correctly in my head or showing the work. So I'm going to make a fraction and just copy these values in. So we want all 6 of them. Whoops, messed that one up. 12C6 over. And this is where using a calculator might be helpful. Is if I hit second, the negative, I can just pull down that 230,230, which reduces to 6 over 1495. And again, I'll accept either answer, unreduced, reduced, or the decimal. If you hit math, the second option will change it to a decimal. And it's a 0.004, or I keep doing that. Or a 0.4% chance. So again, I'll let you leave your answer as a fraction, as a decimal, or a percent. What about if there are 2 of each type? I'm kind of tired of this color. So what that means is that we have 8 tulips to choose 2. We have 12 roses to choose 2. And we have 6 daisies to choose 2. And it's the fundamental counting principle, so we're going to multiply those together all over, because we're doing probability, the total that we want. And I'm sure you guys already looked at the answer key. You can hit pause and see where we're getting these values from. Trust a calculator. And this is just plugging into a calculator. That's why I have no problem showing you the answer key. And then that's what we want divided by the sample space, which we found in part A, which reduces to this number. You can leave it as a fraction. You can change it to a decimal or change that to a percent. I do need to explain letter D because there's a key word in here, the OR word. So it's impossible to have all tulips and all daisies at the same time. So that's a clue for me that we're going to use a plus sign. And when I say that it's impossible to do both at the same time, that's a phrase that's mutually exclusive. That you can't have all tulips and all daisies at the same time. So we add those probabilities together. So when we look at the tulips, there's 8 of them, and we want all 6 that we choose, all 6 flowers to be that, or we have 6 daisies, and we want all 6 of them, all 6 of the flowers. And pretty clear that that answer is going to be 1 over your sample space. Messed up that math. So that's why the or turns into a plus sign. And if you already looked at the answer key, because I've pulled it up twice now, you can see this is what I was talking about. The C6C6 is equal to 1. We've been practicing that enough that that should be obvious. I guess this does not reduce. Makes sense. 29 is a prime. Or you can change it to a decimal or change it to a percent. So exercise 4, again, you can see it as a reduced fraction, but we have Franklin, who has 5 quarters in his pocket, 2 nickels, 3 dimes. I think that's supposed to say dimes. If he pulls 2 coins out at random, what is the probability that he has 50 cents in his hand? So a little bit different of a question, but I hope it's not too hard, because there's only one way to have 2 coins to be 50 cents. And that's with 2 quarters. So the coins must be quarters. So when you look at we have 5 quarters in our pocket, and we're trying to get 2 of them. That's our desired amount. But if you add up, there's 5, 6, 7, 8, 9, 10 coins total in his pocket. He's trying to grab 2 to equal this. So again, I'm not trying to get fancy. I'm just going to use my calculator. Math fraction, alpha x makes the fraction over to probability. Didn't want that. NCR, again, the order doesn't matter. And then math probability 10C2 reduces to 2/9. And again, the calculator is smart. It knows that you want to reduce that fraction. So I don't mind if you just circle your answer or you go ahead and put the number option down. That's fine. Here's another one where you can see kind of the different possibilities. So Harold draws 5 marbles out of a bag that contains 12 red, 10 blue. Which of the following would calculate that Harold draws out 3 red and 2 blue marbles? So here's your and statement. So we can have this happens at the same time. So that's your fundamental counting principle, where you're doing 12, we're choosing 3 red, and we're doing 10, we're choosing 2 blue over the sample space. So the fundamental counting principle says to multiply those options together, and then to find the probability, highlight probability, I'm kind of all over the place, you divide by that sample space. So option 2 is what we're looking for on that one. So this one is kind of weird because it's not even dividing by the sample space. This one is the probability that you're choosing all red. And this is an or statement. Like you're finding the probability of getting 3 or 2 blue. So that's not good math. So option 2 is what we want. And then exercise 6, then you should be ready for your homework. He's trying to form a 6-person volleyball team. It has 10 girls, it has 14 boys. There's 16 that he gets to choose. What's the probability that the team will consist of all girls, or is that key word of adding those together? So our sample space is we have 24 total. And we're trying to choose, and again, the order doesn't matter. Who cares if you're the first on the team or the 6th person on the team? We're doing a combination. But of the possibilities, we could have 10 girls to choose 6, or our plus sign, we have 14 boys to choose 6. And one of those answers must be correct. So I would go straight to a calculator. Alpha x, make my fraction, math. NCR. Hopefully you've gotten good practice at this. 10C6. And then plus. There's 14C6. I haven't shown you this because I don't use it very often, but there is an alpha shortcut, like alpha zoom, I believe. Nope. Alpha window. There it is. Alpha. If you hit alpha window, there's a faster option to get NC, but I don't use it very often, so I often forget about it. Anyway, when you look at this is your decimal 0.024 if you round the way I like to, but if you change it to a percent like they do, they want 2%. Is our answer. And just to double check out of the right answers, I'm just going to go to the calc. Yeah, we had option 4, we had option 2, and we had option 2. And you should be ready for the homework. So I already accidentally worked through the first problem of the homework. I was making a video and didn't dawn on me until after I finished the first problem. I was doing the homework and not the notes. So if you want the video on this first homework problem, I did share it with you. So it doesn't make any sense for me to delete that. But anyway, the homework is not too long. I don't think it is. It's only 8 problems. And then I'll see you in the next video to do the section 10.